I'd like to tell you about a partnership we agreed last year with BSI, the Department for Business, Energy and Industrial Strategy. It came about because we had a new energy management standard due to launch, aimed at small and medium-sized organisations to help them reduce energy consumption and therefore reduce carbon emissions. Now, there's a lot that any organisation can do to support their journey to net zero, but reducing energy usage is a key part of it. I asked BSI if they'd like to partner with us on the launch of this new standard, knowing the standard would match their aims to support SMEs on their journey to reaching net zero. They were really enthusiastic, so I asked them if they'd like to sponsor some copies so that they could be offered for free download. They agreed they'd sponsor 100,000 copies of the standard. We created a special version of the standard and a guide to using it, and both are available for free download from our website. So if you'd like a copy of our phased approach to energy management standard and a free guide, please visit the website. The link is in the chat, but you can just Google BSI 50005 Energy Management. We have a webinar coming soon, so keep an eye out for that and come along and ask our experts any questions you'd like an answer to. Please do share the link with your members, colleagues and friends so they can see how their organisations can benefit from the standard.
So good morning, everyone. Thank you very much for joining our webinar today, covering transition to net zero in the healthcare sector, which is part of a series of events that we're running as part of BSI Net Zero Week. My name's Rob Turpin. I'm Head of Sector for Healthcare at BSI Knowledge Solutions, and I'll be introducing this session, which will comprise of 2 presentations followed by a Q&A session. Now, we last ran this event in early 2021. And since then, a lot has changed, and the focus on sustainability and net zero in healthcare has grown exponentially. We've seen the NHS set itself some very ambitious targets and plans for working towards net zero. We've also seen the International Organisation for Standardisation, ISO, through its London Declaration, make a commitment to ensure global standards support climate action and advance international initiatives to achieve our global climate goals. And this morning, we're going to be focusing on the challenges faced by the healthcare system and those that supply medical equipment and technologies to health and care providers. A little bit of housekeeping first. And just to say this, we've got a lot of people on this webinar, so this is a listen-only webinar and it will be recorded. We welcome your questions via the Q&A function that you will find at the bottom of the webinar screen. So please submit any questions you have to the panel. We've already had some questions submitted in advance, but please submit further ones and we'll try and get through as many of these as we can in the final 20-25 minutes of this session. If you have any difficulties, please also submit any problems you have through the Q&A function and we'll aim to deal with those. Upon completion of the feedback survey that we'll send out at the end, BSI will forward the presentations and a recording of the webinar to you. And this is a CPD recognised webinar, so please request your certificate via the feedback survey following the webinar. Okay, I'd like to introduce our expert panel. We're going to be hearing from 2 expert speakers this morning who will be providing their own experiences and perspectives on the topic of sustainability and net zero in healthcare. I'm delighted to welcome Michelle Sullivan, who's Head of Public Affairs at Boston Scientific, and also Cormac O'Prey, who's the Principal and Director of the Kestrel Consultancy Group. And I'm also joined by my colleague, Lena Cordy-Bancroft. She's our sector lead for medical devices, and Lena will be facilitating the Q&A session that follows these presentations. And so first of all, I'd like to introduce our first speaker, Michelle Sullivan. Michelle is a graduate biologist with a long-standing career in sales, management, marketing, and market development. She retrained as a health economics at York University, and she currently works as Head of Public Affairs for Boston Scientific. She sits on the board of Health Tech Ireland, leading the market access workstream. And in her current role at Boston Scientific, she's in charge of one of the commercial EMEA work streams with regards to environmental sustainability, and is currently completing a course in sustainability in business with the University of Cambridge. She's chair of the Sustainability Group and vice chair of the Commercial Policy Group at the Association of British Healthcare Industries, ABHI. So Michelle, welcome, and over to you.
Thanks very much. Really pleased to be here. Welcome everybody this morning to this very interesting discussion. And we just heard that a year ago was when we first looked at this topic. And a year ago, if you'd have asked me to be on this panel, I would have absolutely fainted because I wouldn't have had a clue what I was talking about. And it was about this time a year ago that I was asked by NHS Supply Chain, what's a Boston Scientific doing about sustainability? And I said, oh, I don't really know. Let me go and find out. And I went away and spoke to lots of different departments within my organisation and discovered, well, in certain places we were doing really quite a lot, and I had no idea about it. And I ended up joining a team called the Green Team, which was just mentioned there. And as part of that, I set up a commercial work stream thinking about what Boston Scientific were doing and the ways in which it would help our customers to match their environmental sustainability goals. And I started this course with Cambridge University, which I'm pleased to say, since I wrote my bio, I've just finished and passed. So that's great. And I feel confident to start to have this discussion. Everybody that I've met in this world isn't confident that they know everything, and everyone's a little bit building the plane as it's flying. So please don't feel like you should know everything, and I've still not met an expert yet in this world who thinks they do. So welcome to the challenge. We're all in it together. So I thought I'd start with the beginning of my journey, because actually I used to listen to all these terms and I go, okay, well, what does all this mean? And what is that talking about? And what difference does that make? So here's my little journey that I went on to start off with, and then we'll move into what's happening right now and the ways we need to think about it. So greenhouse gases include carbon dioxide. They talk about carbon dioxide equivalents, but also includes methane, nitrous oxide and hydrofluorocarbons. And you'll see from the total greenhouse gas emissions that I took from this report in 2019 that in Europe, United Kingdom is second on the list of the greenhouse gas emissions. And when you look back in 2012 at the top greenhouse gas emitters of the world, we have China and then the United States and then the European Union. And it's worth bearing in mind that historical emissions from back in the beginning of emissions time means that the United States is responsible for 25% of all emissions that have happened through time, and the United Kingdom is responsible for about 12%. So we have some work to do to change what's happening and move towards our goal, which is net zero. Something that I really think is important is to understand that these things are very burning platform, and the sorts of effects that are happening in the world right now are only going to get worse, and we can't just walk away from this, and we haven't got very much time. So the IPCC report just came out. It actually made the news. It made the news quite a lot. It even cut through the Ukraine crisis. And unless global greenhouse gas emissions peak no later than 3 years from now and are cut nearly in half by 2030, the world will likely experience extreme climate impacts. That's what this report from over 1,000 scientists who all agree, for once, unlike usual scientists, that this is a thing that's happening. So we've got to take it seriously. If we don't do anything, you can see on the top left the average warming projected by 2100. And you can see on the right all of our energy usage in this very short space of time that's contributing to these emissions and why we're in the pickle that we are in. So why do we care? Well, I've taken a few photographs here from the World Press Awards this year. When you look through them, there was quite a few that were on the subject of sustainability. On the left, you'll see a picture of part of the Amazon rainforest. And on the right, you will see this poor lady in Greece whose house is about to be engulfed in flames from the wildfires that were raging on the 8th of August last year. Now, you will notice and know that these events and the stuff that's happening in the Amazon rainforest are getting more and more frequent, and we need to stem the tide, and we're in charge of what we do here in Europe, and we're in charge of what we're doing in our world of medical devices within our healthcare sector. So let's get on with it and start doing something. You can see lots of impacts of climate when you start looking around. I found this little infographic. If we don't keep things to 1.5 degrees, then there really is things start to happen that we just don't know what they will mean. For example, there'll be ice-free summers in the Arctic at least once every 10 years. I saw something on Twitter the other week, which was saying that the Arctic at the moment is 40 degrees centigrade higher in average temperature than it usually is. That's 40 degrees centigrade. It's usually minus 47. It's minus 7. And I also saw yesterday that in Bangladesh, they have temperatures exceeding 50 degrees centigrade happening in parts of their country. These temperatures are unsurvivable as a human being. So, what are we going to do and how are we going to do it? Well, at the moment, we've got to think about moving from a linear to a circular economy. Another thing I didn't understand before I started looking at this stuff. So, we've got to move from this arrow on the left, take, make, use, dispose, pollute. And we've got to start to think about make, use, reuse, remake, recycle, and reduce our use. And we're quite a long way off this. And we also have to think, well, okay, in the grand scheme of things, when we're dealing with patients, what difference is this thing that I'm doing to them going to make? So, for example, when you're thinking about waste, every night you stay in hospital, is between 3 and 13 kilograms of waste, of which 25% is plastic. So if you can reduce that stay in hospital to a day stay, then you're reducing kilograms and kilograms of waste. And these are things to take into account. And you start to see why it gets a little bit complicated. And some decisions that you might make aren't always intuitive. So bear that in mind as we work our way through this. So here's this little infographic that the NHS have put in its net zero plan. And you'll see that it talks about different scopes of emissions. I didn't understand what they were either a year ago. So I thought I'd put a little bit in here just so that this means something to you. And what we're going to have to start thinking about is the NHS is saying, okay, we want to reduce our emissions, we're going to reduce our fossil fuels, we're going to look at our facilities, we're going to think about our anaesthetics and our fleet, making things electric. But what we've got to understand is that we're part of the problem of their scope 3, which is a big whack of their emissions. And so that's why they're asking us to do what they're asking us to do. And, you know, again, have a little think about the different things that we do that stop travel. This is outside greenhouse gas protocol, but the NHS cares about it. So if you're going to do a procedure which is a day stay, then guess what? You haven't got any visitors coming in and out. And if you're going to remote monitor, then, oh, guess what? You haven't got anybody coming in and out of the hospital. So these are all things to think about when thinking how you're going to help our customers reduce their emissions that they care about. So this was from the plan again, and you'll see what a big part of the pie we are. It's worth bearing in mind why the healthcare sector is under the spotlight. and we're responsible for a massive over 4% of global emissions and 4% of greenhouse gas emissions in the UK. It's a lot, and that's why we're looking at this. And you will also see that from the data that was collected with regards to this, that 71% are from Scope 3, which is healthcare supply chain. We're not brilliant as a nation either. When you look at the global footprint of healthcare, Australia, Canada, Switzerland and the US do beat us, but we are in the major emitter sector between 0.5 and 1 tonne per capita from the Healthcare Climate Report from ARA. And here's what the NHS want us to do. You look at the green section here, reduce single-use plastics by 385 tonnes, reduce greenhouse gas emissions by 3,025 tonnes. We're going to be asked how much we're going to contribute to that reduction. And here's our specific goal in the plan, highlighted in red. And you will also have noted that from the 1st of April, NHS England have extended the reach of PPN 0620 to the commissioning and purchase of goods and services by NHS organisations. So we're right in the start of the storm, and we will have to do things. So what sorts of things can we be thinking about right now? Well, this is a great event, right? It's a collaboration. I'm here as a representative and the chair of ABHI Sustainability Group, and we can all work together, as BSI have stated in their article, to turn the international standard system into a tool to help the world get to net zero, as we heard in the video at the start of this. I've put in a little example of something that I learned about as part of my Cambridge course, our closed loop value chain, something happening with a project called the Real Car Project. And they are looking at what I described, which is how to build a car using only aluminium, etc., that is recycled, and then once it's finished with, moving it back into that circular economy loop. And I figure if car manufacturers can do this, then maybe medical device manufacturers can do this too. So what sort of stuff is going on that is a challenge to us and how we have to think? Well, I attended an event called the Net Zero Operating Theatre that was publicised by ABHI a little while ago. And this was the Royal College of Surgeons of Edinburgh, co-hosted by the Royal College Leeds of Scotland and England, talking about how to make their operating theatre net zero, with a lot of data and interesting facts about different operations and the carbon footprint and contribution to emissions from different things that were used in the operations. They highlighted lap colis and looked at 3 different devices that were responsible for a huge proportion of the greenhouse gas emissions carbon footprint of that operation. And the suggestion was that by moving to reposable or reusable, then you could reduce your emissions. So what we have to think about is the ways in which we need to improve how we go about packing our products, what they're made of, the way in which they're made, how we can help with the disposal of the different parts of it, and the ways in which anaesthetics are used, which you saw was in the Scope 1 plans of the NHS. And, unfortunately, there doesn't seem to be any way to get around this. Anaesthetics is a big part of the carbon footprint, and they will be addressed, and you'll see it in all the NHS plans. So, how are we going to help with that? What sorts of things can we do to mean that they use less anaesthesia during their procedures? Something I wanted to mention was a sort of move away that's going to happen in the future in litigation risk. And a lot of us work for big American multinationals. We are concerned with litigation risk, particularly for individual risk in terms of infection control and safety. And these things will always be important, but it's worth bearing in mind that this type of risk will not be the only type of litigation risk. And it's starting now, and it will only increase. And that litigation risk will move away from, okay, well, here's the thing that we've done to make it the maximum safety amazingness for an individual patient. And it will move to the population. And well, what are you doing to reduce greenhouse gas emissions and your carbon footprint, because you're contributing to a climate crisis, and that's an existential event that affects everybody in the world. So we will start to see a little bit of move away from one type of risk to another type of risk. And who knows where it will end up, but it's worth thinking about, understanding and knowing. So we're moving towards the end now. What do you need to do? Well, keep it on track, reportable and defendable, right? There are frameworks that exist to set targets, and there are frameworks to disclose on progress. And you'll see a number of companies partnering with the Race to Zero. Boston Scientific have done so. And you will also see that the NHS is asking for us to disclose on progress via frameworks like the Carbon Disclosure Project. So positive steps for you to take. Become carbon literate. That's what I was talking about at the beginning. For those of you that aren't, I've tried to help you with some of the simple stuff, but it really is important that everybody knows what it is we're talking about. And as a result of that, if you manage to get everyone in your organisation carbon literate, then you will change your organisation's culture, because it's really impossible to understand this situation and not want to do something about it. Collaborate and learn from other industries. I talked about the car industry. I've met people from Auto Trader who have become totally carbon literate as an organisation in the last year. Partner with those who've had success and think about the companies that might be a little bit further ahead on this journey than you are. Work with similar companies to achieve your aims. We're not going to be able to do this individually. Some of the stuff we're going to have to do, we're going to have to all club together and go, okay, how are we going to dispose of all this stuff, and find a way to do it. Follow a framework to set your targets, as I've said, and follow a framework to disclose on progress. And these are things that you can do that are positive to move you forward. And do not lose hope. There's a brilliant TED talk, I encourage you all to watch it, from Christiana Figueres, the inside story of the Paris Climate Agreement. And she didn't think this was possible. The night before it, she blurted out that it was impossible the night before that she was asked to take the job. And it's a really inspiring little film that you can watch. There are articles coming out all of the time on this topic. It is possible. This is the group that I'm working with, the ABHI Sustainability Group. I'm the chair, Richard Carter's the vice chair, and Luella Trickett runs it. And at the moment, we're working with ARUP, and we've created a report that any ABHI member can get access to. We work obviously with the BSI. I work with Health Tech Ireland. We work with MedTech Europe, NHS Supply Chain, NHS England, and NHS Improvement. Thank you very much for your attention. I'll look forward to the questions afterwards. I don't promise to know all the answers. And that's me. Thanks a lot. Handing over to Cormac.
Michelle, thank you very much for those fantastic insights. Really great to hear those. And on that last point, the ABHI Sustainability Group, really look forward to working with you on that group going forward. Now we're going to hand over to our second speaker. So I'd like to introduce Cormac O'Prey, who's Principal and Director of Kestrel Consultancy Group, which he founded in 2017. Cormac is also a member of our BSI Standards Committee that's responsible for the BS 8887 series of standards, which cover design for manufacture, assembly, disassembly, and end-of-life processing. And as part of that, he's taken on a lead role in terms of standards for sustainable device design, specifically for the medical device industry. So, Cormac, thank you, and over to you.
Thank you very much, Rob, and thanks again to Michelle for a fascinating set of slides. I look forward to going over those in more depth later. Right, I guess nobody's really heard of Kestrel Consultancy Group because, to be honest, it's really just me and my wife who looks after a medical editing business. So let me just make sure I get these slides to work. There we go. So just to give you a little bit of structure as to what I'm going to try and cram in over the next 20 minutes, and there is quite a lot to talk about, so forgive me if I talk over the slides and you can digest them at your leisure later. There's quite a lot of detail in here. So first of all, I'll give you a couple of minutes on who I am, why I'm speaking to you, and why you might be interested in what I have to say. Then a more of an introduction as to what sustainability is in medical device design and manufacture and why it's important. We'll then go into a little bit more depth in terms of what the drivers and priorities are, why we need to pay attention, what the consequences are if we don't, and who it matters to. What's involved in sustainable design and manufacture? How, as designers and product manufacturers, do we actually do this? Where do we need to focus our attentions and how do we measure success? We'll then look at what we actually know. As Michelle mentioned earlier, there are examples of success both in other industries outside medical, but also if you look hard, there's examples of what good sustainable design and manufacture looks like that have already been well established within medical, in some cases for over 30 years. So what can we learn from other industries and from our own industry so we're not going through the pain of discovering this for the first time ourselves? And there's a lot to be learned. I'll then spend a few minutes talking about the role of BSI. Why is BSI getting involved in this, and what are our aims and objectives? What are we trying to contribute, and why? And how can we hope to help industry achieve what their aims are? We'll then talk about what the next steps are, some of the challenges that we have ahead, and how we plan to overcome them. And then, as Rob mentioned, we will go to the end of the session for some questions, and I'm looking forward to some of the feedback that I get from you about that. So, quick introduction to me. I am a professional medical device development engineer. I've been doing it for about 20 years, and there's a list on the right-hand side of some of the companies that I've worked with. So, my focus as a medical device engineer for most of those 20 years has pretty much been exclusively on patient safety, with, of course, the required attention paid to things like economics, manufacturability, etc. As a side interest, as Rob mentioned, I've been on the BS 8887 Design for Manufacture, Assembly, Disassembly and End of Life committee since about 2005. I've recently seen these two streams come together, and it's a very exciting time to be involved both in medical device design and development, which is still my day job, but also seeing how some of the things that we have developed over the past 15 to 17 years on sustainability and design for sustainability are now attracting a lot of attention in medical, and what's behind that, and what can we learn, what can we actually add to the mix to help medical device companies achieve the kind of really hard sustainability targets which are being presented to them. Okay, as Rob already mentioned, I am the project lead on BS 8887, which is a branch of the Sustainable Medical Devices Group, looking specifically at design and manufacture. And I'll go into a little bit of the structure in that later. Also, as another side as part of what I do, I'm a lecturer in engineering design and global business environment and international strategy in Cambridge. Okay, so let's start with what we understand by the word sustainability. You ask 10 different people, they will probably give you 10 different definitions of what sustainability actually means. It covers a huge range of material. You want to go back to the source. The UN is probably a good place to start. And according to the 1987 Brundtland Commission by the UN, sustainability is involved in meeting the needs of the present. That's important. We're not talking about forgetting what we need to do today. This is still about meeting the needs of our customers, our society, ourselves, our colleagues, our families, etc. today, but without compromising the ability of future generations to meet their own needs. So this isn't a sacrificing today to help people tomorrow. This is a win-win scenario we're aiming for. And if that doesn't work, then really the solutions don't work. So in terms of what we do in the medical device industries and as manufacturers, for today's businesses and outside as well, this has tended to boil down to four key areas. As Michelle already mentioned, CO2 and CO2 reduction is by far the highest priority. This is the main contributory factor towards global warming and all the horrific consequences that are projected to come from that scenario. Global temperature rise, sea level rise, wildfire, direct effects on human health. This is the main focus. As well as that, we are also focusing on energy management, which is a direct contributor towards global warming, water management, and how that's affected by global warming and environmental change. But also within the manufacturing industry, we are also looking at waste reduction. So in terms of engineering, design and manufacture of medical devices, you may ask, well, what's the point in focusing on that if the real question is about CO2 emissions? Well, the fact is that 80% of the CO2 that is released by manufacturing any device anywhere, but including medical, can be reduced by incorporating some of the techniques and approaches which we'll talk about a bit later in the slides. So it is all part of the same scenario. Okay, so without going into too much detail here, why should medical be concerned about sustainability, and why now? Sustainability has been around for 20 years plus, 30 years if you go back even further in some industries, like electronics and the car industry. Why has medical suddenly woken up to this? Well, there's been some research done in the past few years which shows that we are not just affected by sustainability issues, including CO2 emissions and also plastic waste, but we're also one of the leading contributors for it. And for people who dedicate their lives in an industry to making people better, finding out that we are responsible for 9 million premature deaths as part of pollution, and that actually if the healthcare industry were ranked alongside other leading nations, we would be the 5th worst in the entire world when it comes to greenhouse gas emissions. So we are not just responsible for helping people deal with this, we are responsible for the problem itself. And in fact, from some cases, medical is actually making a bigger contribution towards global warming than the airline industry, just to give you some context. However, looking at what we actually focus on in medical, we have supported a normalization of excess and disposability in developed nations. But plastic waste, including used plastic medical products and packaging going to landfill or ocean dumping, is simply no longer considered acceptable. So if we decide that this is something which we are responsible for, it is also something which we are having to deal with the consequences of, the next question is, what can we do about it? And where does what we can do about it fit into the overall picture? Well, as I mentioned earlier, sustainability covers a massively wide range of things that society and companies can actually approach. And this is a snapshot on screen of where some of the main areas are. So within a company, you will have layers of sustainable operations, sustainable manufacturing, sustainable production, sustainable products, and then within that, sustainable design. And within the 888-7 committee, and as part of my day job as medical device designer, my focus has really been trying to be on sustainable design. You also need to take consideration of external groups, of course, like suppliers, customers. Look at what happens to your products once they've been used, which includes waste management, and then, of course, what the influence of regulators are, who again are starting to wake up to the needs of including sustainable credentials and sustainability measurement as part of medical device development. So there are a number of tools which can be used. If we decide as designers and manufacturers in the medical device industry that we need to reduce our waste and we need to reduce our CO2 emissions, next question is, well, how do we start? The good news is that we have options. There are a number of different techniques which have been used successfully in a number of industries so far, and we can learn from these. And the diagram on the screen in front of you really represents a hierarchy of options that are available to companies who want to move from a linear manufacturing model into the circular model that Michelle mentioned earlier on. The reason why these are ranked as a hierarchy is because these are options available to business, starting with the ones which are most attractive to business, but also most attractive from an environmental point of view because they represent least cost. They also represent the maximum amount of recoverable material to avoid any further energy emissions and any further waste going to landfill. And that's our ultimate goal. So not surprisingly, top of the list of options that you have is to recover products that you already have manufactured from your customers, reprocess them, and then return them back to the customer. Now, this makes a lot of sense for a number of reasons. First of all, because if you're recovering used products from your customers, they're not going to landfill. They're not being broken down. They're not even being recycled, which in itself can be a very high energy intensive process and not particularly profitable. But if as a manufacturer, you can actually recover the product which you've already sold, in a lot of cases, a high proportion of that product is absolutely fine. That it hasn't degraded, it hasn't worn out, it hasn't become contaminated, and with the right thinking and the right processing behind it, can be returned back to use with the customer as part of its original purpose. So that obviously makes more economic sense for a manufacturer than simply recovering material and grinding it up or putting it into landfill, because it represents a revenue stream. And this is where we get into the interesting area of medical manufacturing, where who pays for it. Most of the options available when it comes to reducing our carbon footprint or reducing our waste plastic emissions are cost negative. They actually cost the business something to do. And that, as a business case, is really not sustainable long term. We need this to pay for itself. So to do that, it needs to generate a profit, it needs to generate revenue. And to do that, it needs to be involved in the revenue stream, in the value stream. And somehow that has got to be sourced back to your customers so your customers can pay for it again. There are some options around how to do that in terms of whether the customers refill existing devices or return devices to be refilled, and what the cost of those is compared to what the value is to the customers doing it. Okay, so what does this actually look like in practice? Well, traditionally, as Michelle mentioned earlier on, linear manufacturing looks pretty much like this. It's a nice simple process. Designers and manufacturers get materials in, we get brought in components, we assemble them, packaging, distribute them, and then they end up with pharmacies or hospitals through to patients and then disposal. That's pretty much when we lose track of them. Quite a lot of them end up in landfill. What we're aiming to go for is something that looks a little bit more like that. And as you can see, it is more complicated. It's more complicated because it aims to look at what the different options are for components or even parts of components in current designs, and what is the best route for them, the best for environmental sustainability, but also the best route for the business. So if you can recover something and reuse it, then you should. What is putting a lot of companies off is the fact that everything in this yellow box in the middle doesn't currently exist. This is new, and it's a little bit scary. It's a little bit scary because it means that there are whole disciplines here and functions that need to be embraced to make this work that currently don't exist within businesses. Now, there are some third-party manufacturers, for example, in surgical equipment, who have already taken the initiative and have started recovering and refurbishing and reselling used medical devices. The relationship between those and the original equipment manufacturers has been problematic, but there are some companies that are still working towards making that work. But the key thing is that if you can actually return a device back to its original designer and manufacturer, that original designer and manufacturer then is in a position where they can warranty that product to be as good as new. And quite often, if a device is designed to be reusable a number of times, it then becomes economically feasible for the manufacturer to make that design better quality. If it's got to last longer, but you can sell it multiple times, then you can invest more in the actual manufacturing and design in the first place. It's a bit like, getting a cheap second-hand car, which may last you a couple of years, but every couple of years you need to buy another one. Or maybe you invest in something that's a bit more expensive to start with, but actually could last you 15, 20 years. Overall, the cost of ownership of the more expensive car is less, but the outlay can be higher, and you can afford to put more quality into it. So in terms of progress and how we're actually dealing with this at the moment, this is pretty much where we are. The process for recovering used devices from other industries, including recycling, that is under development. The recycling industry has companies like Recycle-I, who have now started developing automated waste recognition and sorting system. So once you get your used products back again, the first question you have to do is, well, what do we do with it all? We can't present a skip load of used devices to a factory. They'll tell us to get lost. We need to present them with something usable. So steps need to be taken to turning waste stream into usable products stream or reusable product stream. So it starts with recognition. There are techniques that have been devised in terms of reverse vending to encourage people to return their devices. There's automated disassembly, which has been developed by Apple for their iPhones. There's even standards for cleaning medical devices that will allow them to be introduced back into the value stream and back to patients. These are over 10 years old by the AAMI. And in terms of development of the technology to allow this to be realistically economically feasible, there are international workshops on autonomous remanufacturing, which have been going on for a number of years. This particular one was run in Beijing last year through a collaboration with BSI and some Chinese standards partners who we're working with to try and make this actually work in practice. So we'll come back to this, but the big elephant in the room, the main block to making this work at the moment, and where I believe we need to focus our attention, is in the red box here. It's in actually making recovery of medical devices work. This has been tried in the past and it has not been successful. And with the best will in the world, you can design your products to be remanufacturable. You can make your remanufacturing operation nice and slick, make it efficient, make it cost effective. If you don't have recovered medical devices and recovered product to work with, it will not work. So if you want to focus your attention, I suggest that's where we start with. It's how to incentivize people to return their devices, or how to incentivize medical professionals to return devices that they use on patients. Okay, so if you decide that you want to do this, where do you start? It's a fact of life when it comes to sustainability that affects pretty much every single aspect of an operation. That makes it high risk, it makes it potentially disruptive, it therefore makes it a bit scary, and quite often companies will spend a long time thinking about doing sustainability but will back away from it because they just don't know where to start. Okay, well here's a few examples or a few ideas about how this can actually work. So quite a lot of discussions around this subject talk about the life cycle analysis. You need to know what you have before you start to change it. You need a baseline. You need to understand that when you bring about any kind of change, how you measure that change, and when you report back to your company what effect that change has had, you need to show a before and after. So one of the first things that companies need to do, and this is really good exercise to go through that will kind of show them in an objective, measurable way how their environmental performance is. And we're not just talking about stuff that's coming in the factory gates and then going out the factory gates. We're talking about the entire chain. So if you're talking about the CO2 impact of your manufacturing operations, you may need to go all the way back to extraction. You may need to go back to the polymerization plant in an oil refinery somewhere that has actually produced the plastics. Because if you're looking to demonstrate an improvement on that, where you do not need to source that plastic to make your devices because you're reusing devices that you've recovered, then that counts. So once you've got the analysis done, you can then start to say, well, now we know what could be achieved within our organization. Let's pick something that is relatively short time scale, low risk, and low cost, just to demonstrate the principle. Because a lot of people within the organization and indeed in wider society are still quite skeptical about if this is even doable. And if it is doable, how much it will cost and how much pain you'll have to go through as an organization to do it. So it really does pay to demonstrate with a small, easy win project how to actually make this work in principle, just to communicate and convince people that this is what you can do. If that is successful and you demonstrate to everyone's satisfaction that this is something that can be rolled out across the rest of the organization, then you need to integrate it not just as part of your manufacturing operation, but as part of your design thinking. Things like modular design, platform design, where whenever you recover products, it is easier for your entire operation to deal with them. You're not creating problems for your manufacturing operation. In fact, you're there to make their life easier. So let's look at some examples where this has actually been done in the past. I did mention earlier that in some industries, and in particular even in medical, this has been done for a while. Typically because of the nature of their design and the relationship with their customers, high value but low volume medical devices have been manufactured, recovered, and remanufactured for some considerable time. Two main cases are Siemens Healthcare and GE. We have a representative of Siemens on our British Standard BS887 Healthcare Committee, and they provided with some background as to some of the things that they've been doing. So you may look at a high-end CT scanner or NMR machine and think, well, if this has a design life of about 7 years, what happens to it after that? Quite often, if a machine is recovered, 80% of the components in it have not worn out. They have not degraded, so they can be reused. Things like the IT systems, things like the imaging system, the computing system, which may be obsolete by the time the next remanufacturing run comes around, they're separate from the main unit. Therefore, they can be upgraded without needing to necessarily dismantle the main unit and rebuild it, which of course has all the associated cost and risk with it. Again, taking this thinking even further, GE have been doing this with their what they call heavy iron products, for example, CT, NMR, and X-ray machines, for more than 30 years. Now, 30 years ago, sustainability in healthcare wasn't really a thing. So GE did this for economic reasons. They realized that recovering these machines, and which can be like $5 or $6 million each, and disposing them and then replacing them with new machines didn't make a huge amount of sense. It was much more economically viable to try and reduce the cost of these devices so a hospital could afford them, But to make that work, they actually incorporated this thinking into the design process. So the heavy iron products and components within some of these machines, which have to last for multiple lifetimes, are designed to do specifically that. So some of the components in these scanners are designed to last up to 30 years, even though the design life for each individual machine is only about 7. And this is kind of what this looks like. So a traditional manufacture would look something like this, starting with the design spec, design, manufacture, use, repair, and resale. The alternative approach looks more like this. Okay, where regular servicing, regular recovery, rebuild, and reuse allows the economical support of customers who really do want to have the latest technology, but cannot afford to be spending $5 or $6 million every 7 years for a new machine. Okay, so just check the clock, and we are running a little bit out of time, so I'm going to quickly skip through the rest of this and get to some of the main points. Michelle mentioned earlier on about the circular model. The circular model is an interesting one, but in the context of machine designers and medical product designers, there's a slightly different take on this, which I think we should be considering, and this is what I call the spiral model. The circular model, by its design, shows how you start with a design, and then as you go through the cycle, you come back to where you started. In the real world, that's not how we work. If we have design cycles, for example, in NMR machines of about 7 years, remaking something that was made 7 years ago is not really an option. So when we're considering how to design medical devices for sustainable manufacture where they will be recovered and remanufactured, we also need to think about what will need to be changed, what is likely to become obsolete the next time that the device comes back for processing, and what customers are likely to need at some point in the future. That requires a little bit of forethought and a little bit of extra work to try and predict what the needs of the industry will be. But it also gives us the opportunity to include things like smart technology to track what these devices will be doing and inform our manufacturing people what they need to know. So just to conclude, remanufacturing propositions must consider an end-to-end impact for remanufacturing. Remanufacturing is not new. It's not high risk, and it's not compatible with the highest standards of product manufacture. This has been done in medical and other industries for a long time. We just don't know it yet. And there's a lot to be learned from existing best practice. Okay, so risks, I'll leave you to read these in the slides later on, but I think I should probably speak a little bit about British standards and what we're doing. So in the 888-7 overall standard, which is part of TPR 17, if that means anything to you, we have branched out into a number of different areas, and the standard is evolving all the time. The latest one is TPR 175, which is a standard for medical devices that sits along beside another committee for IT equipment, textiles, automotive, and furniture. And the reason why it's structured like this is because we want to steal all the best ideas from all these other industries. And by having an organizational structure like this, we can do that. We don't have to learn everything from scratch. A lot of the best lessons have already been learned a long time ago. We just need to pick them up. And that's what our current committee looks like. So our aim was to have a selection, a cross-section of all the key opinion leaders and voices that need to be heard in the conversation about sustainable design and medical. We're still looking to recruit more people, but having a cross-section of people from pharma, manufacturing, standards, research and industry, design consultancies like mine, and manufacturers, this gives us the credibility and the confidence to say, yes, we understand the issues, we understand the context, and we also understand how some of the solutions can be developed. So I think I'm just a little bit over time. I think I better hand over to Rob now. I'm sure he's got more things he'd like to do.
Thank you, Cormac, and thank you, Michelle. I'm not Rob, as you can tell. I'm Lena Cordy-Bancroft, and I am going to, with BSI, I'm the sector lead for healthcare medical devices, and I will be facilitating the Q&A then with our expert speakers today. So we do have quite a few coming in. For the attendees, please feel free to drop your questions into the question section of GoToWebinar, and we will get as many of these addressed as possible. Anything we don't address, we will follow up after the session. So, wow, lots of information there to digest. And I need the graphics because it helps kind of put it all into perspective and understand, okay, what is this big picture? Because very much like what Michelle was saying at the beginning of her talk, nothing. I'm like, what? I don't understand any of this, until you really start being told it in a very, okay, my language, I'm not going to understand it, right? So it was very helpful. The first question that we have, obviously this was really looking at the UK perspective, but from the slides and the information that Michelle showed, the US is pretty high up there with as far as being a bad guy, I guess, in the terms of greenhouse gases and sustainability. So do we expect the FDA to become more engaged in these efforts to become more sustainable faster? Or is the UK, are we looking at partnering with them at all to kind of join forces, much like what Cormac was saying, with, find an industry or a company that's working well and work with them? Any thoughts on that?
Shall I jump in first?
Yep.
Okay. Well, first of all, the reality of medical device manufacturing and design is pretty much all the companies who we're dealing with are global. So a solution that fits the UK alone is insufficient. It's worthwhile for global corporations to look at what the UK is doing, because through the BSI committee, which then feeds into ISO and has developed relationships with China, where a lot of the device manufacturing goes on, and how they are approaching circularity. We are kind of leading the thinking on this. But the FDA are very much aware of what the needs of industry and the needs of society are to incorporate more remanufacturing, more sustainability into medical devices. However, a word of caution, there is a problem with some of the terminology. What we understand by remanufacturing and how it's defined in British standards in this country is very different to what the FDA have defined remanufacturing as. So if you're going to have discussions about this, just make sure you're talking about the same thing. As well as that, the regulations in the US are now they're trickling through, where the responsibility for manufacturers to take care of the waste that they generate in the healthcare industry is now starting to bite. That started to be introduced over the past few years. So manufacturers in the US particularly will now have to pay attention to that.
Michelle, do you have anything to add?
Yeah, my two pennyworth is, my observation is that Northern Europe is leading the way, and that includes the UK and Scandinavia. And within my organisation, we know that that's the case. What's great about what the NHS is doing and the government, I never thought I'd actually say those words, but anyway, what's great about what they're doing is that they are in fact leading the way and making people think about what they have to do. So what's going to happen is the pressure will just increase and increase and increase as this wave of responsibility towards the environment washes across Europe, and that it will end up getting everywhere. And as Cormac has just mentioned, there will be opportunity for manufacturers who manufacture correctly in this sustainable world. And I've heard this described as bigger revolution, as the Industrial Revolution. And in order for everything to stay the same, everything has to change. And so the UK will be part of that sort of leading the way charge, really. And that's the way it just is.
I think that's a really interesting point that you guys brought up, because with the fact that this is what's happening in the UK. Is the FDA following, or is any other country following? But what we need is the pathfinder, and that's what the UK is doing, to lead the way and say, do this, because once a manufacturer makes those changes, like Cormac said, well, they're not going to have two different lines of manufacturing going on, a sustainable line and the linear. They'll have the circular production instead of the linear production, and so it's just everything kind of flows through that way. So that's a really good point to keep in mind. If you're going to do it, just commit. So thank you, yes, for that information. Next question, pretty interesting. Should we also think about innovation in medical devices and procedures so that we can have patients out of, for example, hospital faster, and then reducing the hospital footprint? Are there, looking at innovation, not just sustainable manufacturing or the circular economy, but looking at innovations with medical devices and procedures as well.
Yeah, I've done lots of work on this actually, looking at our portfolio, and it was the reason I got really involved in the work stream that I am, because I'm a health economist, okay? And the reality is that if you do a cost consequence analysis or any of the approvals that we put through NICE, they reduction in cost comes from reduction in length of stay, reduction in operation time, reduction in the amount of stuff you're using. And all I did was substitute carbon dioxide equivalent kilograms and waste kilograms for money in some of the calculations, and went, oh, look at that, that's amazing. And I used the NHS's own figures, and the NHS is great for this because they've got lots of figures about these sorts of things. And so, yeah, this is where we've got to join it all up, Lena, because it's not intuitive, right? So I've got this plastic thing. I'm going to do a minimally invasive procedure with it. I'm then going to, currently throw it away because we haven't manufactured it to not do that. And we've got things about infection control and blah, blah, right? But that patient's only going to stay for no days, not 4 days, which we would have with the other thing that we're going to do. And we've proved that. So, this is all part of the discussion. And it's the same problem that we've got with regards to value-based procurement and healthcare, which is the hospital is got to care about the patient population, not the individual patient with regards to this, because they're going to put another patient in that bed. So it's how are we going to start to address this, and how are we going to show the things that they will care about, which is why I mentioned patient travel in and out of hospital and visitors and stuff, because these are things that make a difference. And anaesthetic use, half the procedure times, half the anaesthetic use. Boom.
Cormac, do you have anything?
Yeah, I just come back to what your question was, which is about innovation. I mean, innovation in medical device design is kind of what I do, and definitely there is an opportunity for innovation to, I think, as Michelle mentioned, not just help with the treatments and the reducing the impact of treatment, both in terms of treatment stays, therefore the financial impact on the health services, but more there's an emphasis on prevention. And particularly with the innovation around things like smart drug delivery devices, which are there to try and help patients stick to their treatment regimes, therefore avoiding hospitalization in the first place. And there's innovation been done in things like other smart devices, everything from wearables to smart homes, again, to try and help people tackle their healthcare challenges before those challenges escalate to the point where hospitalization is required. So there's a lot of, I've done a little bit of work on this in the past, but a lot of work been done in terms of trying to help people take better charge and understand what their healthcare needs so they don't need the treatment in the first place. And if you don't have hospitals full of sick people because they never got sick in the first place, we all win.
Yeah, and I think we're working with manufacturers, obviously regulators and manufacturers and stuff. We're looking at the sustainability and the innovation and these changes going forward. I think the next step is talking, making consumers understand, we also have to change our expectations for healthcare. The use of telehealth apps and stuff with especially with COVID, and getting that's a generational issue as well. Making people feel confident and comfortable in some of these changes as well going forward. So there's so many different things that we can innovate, besides just the device itself or the care that we're giving. Michelle, there's a question here for you. How have you managed the collaboration between companies with regard to any confidential product information you may have needed to share?
Yeah, well, we sort of have a bunch of rules at ABHI, and when we into the realms of anti-competitive problems, then we get stopped in our tracks, and it is a tricky one. And I think this is one of those questions where we're going to have to think about it as we go along, because the reality is, as I've described, I can't see, looking at Cormac's model, and the collection of the products that we're going to be reusing, and the packaging, disposal, and all of the different things that we've got to think about. When you try to do that as an individual company, and a few individual companies have tried it, it's really difficult. And so we are going to have to start to think about things as a group. I don't know if that is, going to have to get into that detail, Lena, about what the different competitive things, I can't. It's more about, well, do you have a bit of titanium that's part of your product? Yes. Okay, well, here it's all getting shoved in this bin over here, right? And we're all going to then deal with it, and this is how it's going to be. And so we'll have to see, I believe, is the answer, but we're cognizant of this issue.
I can probably add to that a little bit. This is actually happening at the moment within the inhaled devices industry. Last September in Southport, there was a meeting of the working group on sustainable PMDI, so quite specific, pressurized metered dose inhalers. But that was basically an open forum where all of the major manufacturers and equipment suppliers involved in that industry, particularly with the focus on propellant gases, which is where most of the concern is because of the high GWP of some propellant gases. But it was very much an atmosphere, look, we're all here to solve the same problem because this problem affects all of us. This isn't about competitive advantage, because unless we work on this together as an entire industry, none of us will be successful. And that was very much adopted, and that's kind of the theme and the way it's been working in the background as well. So commercial concerns to one side, obviously. The emphasis is very much on this just has to be made to work, or everybody in this industry is going to suffer.
And that's a really good example, Lena, by the way, because, some of those manufacturers would have been ahead of the game in how they were going about it. And they were sort of helping everyone else to join up. And so, it's been done, so we can do it.
Yeah, I agree. I facilitated a webinar last week on sustainability, and one of our speakers was Matt Morris from the Cambridge Design Partnership. And one of the examples that he brought up was, I believe it was Colgate, their packaging, and it says "recycle me" and all this, and that's fine. But if somebody is buying, another brand of toothpaste, Crest or Aquafresh, whatever, they're not going to be able to do that. So it takes more people involved, and so I believe P&G they open sourced their technology and how they made that their packaging so that others could use it. And I think that's a really very community focused let's look at this globally and a collaboration opportunity that I think we can definitely learn from and benefit from. Good. And let's see why. This next question: why do we think the pharma industry has been more active so far than the medical device industry? Any thoughts on that one? I don't know much, but I don't deal with pharma, so I don't have much to say there.
I would say because the pharma industry, and I could use GSK as an example. I mean, this is public knowledge that I mentioned about the PMDI propellants. They account for 30% of GSK's entire CO2 equivalent emissions. So the pharma industry is concentrating on those because they think that's where the big problem is. Medical devices are perhaps more problematic in terms of the problem is more complicated. Replacing high GWP propellants and other chemicals as part of a pharma manufacturing operation is kind of trying to replace one chemical with another. It's a fairly well-bounded problem, and that's currently where a lot of emphasis is. It's got more complexity in terms of leakage rate and pharmacostability and all that kind of thing. But basically, it's pretty well understood what needs to be done. When it comes to solving the problem with medical devices, which is mostly about waste plastic and how you solve that, it's very complicated. And as I mentioned earlier, affects pretty much every single part of the business. So it's difficult to know where to start. It's difficult to know what approach to take, and in a complicated situation where you have a number of different options, even the process of deciding which option you're going to focus on is not easy. It will take time, just because the problem is more difficult.
Yeah, sort of agree. And contamination's an obvious one as well, right?
Yeah, absolutely.
Yeah. Where do you think, or do you see a link anywhere between carbon emissions, air pollution, and healthcare outcomes? How should these be measured in order to influence a change in behavior?
Say that again.
Yeah. where do you guys see the link between carbon emissions, air pollution, and healthcare outcomes? And how should this be measured in order to influence change in behavior? That might be one that requires a little bit more thought and
That's a
analysis.
biggie.
Yeah, it is maybe a lot of the problems with health, is from things like, car exhaust and stuff like that, right? And air quality and things, so if you're manufacturing in a country with, coal-fired, energy and what have you, then there's a direct link. But otherwise, the point is that by reducing the overall emissions, then you improve the overall health. So we're just part of that big contributing pie. We're like, it's like steel production or cement manufacturing or all of these big emitting, areas. And we have to just acknowledge healthcare is a big emitting area with loads of waste, which has to be dealt with and which is often burned. And that causes problems, right? So that's my 2 pennyworth, Cormac.
I'd agree with that. It's difficult to, because I think when we're talking about carbon emissions, we're really talking about CO2 and CO2 equivalent emissions. And the consequences of more CO2 in the atmosphere is global warming. And the consequence of global warming is rising sea levels, is increasing global temperatures, direct effects on healthcare, but they are displaced geographically, and they're also seen to be displaced in time. So even though we know there is a cause and effect relationship, directly tying how much CO2 equivalent you're going to release from your PMDI inhaler to rising sea levels in Bangladesh, it feels remote. It feels to some people, it feels, well, that's not my problem. I don't live in Bangladesh, and it's not going to happen in the next 20 or 30 years anyway. So why am I worrying about it now? And that's kind of the mindset that we're up against. But it's a problem that is inescapable. There is nowhere you will be able to go once it's there to get away from it. And it's even starting to affect some areas in the UK. As a matter of fact, you can probably tell from my accent that I'm from Belfast, and I had a picture come through from my brother yesterday, where there are now hillfires raging north on the hills north of Belfast. That never happened. This is happening here, and it's happening today, and it's immediate and it's personal. But trying to get that across to and making the connection between that and releasing CO2 equivalent gases is quite hard because there's not an obvious link.
There was something I heard, I know we're going to have to finish soon, there was something I heard from a talk, and it was that the atmosphere of the Earth is 5 kilometers high, right? So you could drive it in your car in 5 minutes. And that's the air that's sustaining the life of the planet and us as a human race. And that's what we filled up to 3/4 with sort of greenhouse gases. We've got a quarter left, and half of that's been in, that bit where I just showed you the huge graph, that's been in that little period of time. And why they're saying you've got 3 years to stop emitting is because there's so many of us emitting so much now that's the time you've got before your 5-minute drive of air is, irredeemably, going to just increase the temperature up and up and up. And it's just
an awful lot of anxiety now when you say it like that.
I know.
It's like,
but it is anxiety deriving, but also everybody says there's things we can do, and there's loads of things we can do. So we just have to keep moving forward with it, Lena.
I think there is one note of optimism. This is not directly related to global warming, but there's kind of an analogy here. I read a couple of months ago that because of the steps that global industry, particularly in refrigeration, has taken with ozone depleting chemicals, that the hole in the ozone layer has now healed. We've done it before.
Yeah, absolutely.
We have fixed this already. So it does sound all doom and gloom. Giving up is not an option, but it's also important to remember that even though we cause these problems, we can fix them, and we have fixed them. It can be done, but it's an engineering problem. You need to deal with this as an industry.
This has been very, very interesting, Michelle and Cormac. I'm just, wow. It's gonna, and now that we've got a bank holiday coming up, I think I might sit and think about this and what can I do at home, and really start to, because this is impacting all of us, and it's, we can all, it doesn't matter if we're talking medical devices or automotive or digital or whatever. There's so much overlap. And the one thing I've said even to my children when they were little, and I keep saying it now to my teams at work, none of us can do everything, but each of us can do something. Right. And that's what we need to keep in mind. And it's just, today we can each do a little step to help do our part with getting one step closer to net zero. So I think even being on this webinar and hearing this information and causing me anxiety for the next couple hours has been well worth it. So I very much appreciate you both taking your time for this. I appreciate everybody who attended and submitted questions. Thank you for joining us. If you're looking for more information on sustainability, you can join us for the Net Zero Digital session that will be this afternoon as the final wrap up to the BSI Net Zero Week. And then, at 2:00 today. And then there will be, I believe there's a survey that will go out and a discount code for a packet of standards related to sustainability. Thank you all and enjoy the rest of your day.
Thank you, Lena.
Bye.